Last night, you may have thrown it in the trash without a second thought. A pile of shrimp shells, a few crab shells still clinging to scraps of meat. What you assume was just kitchen waste after a family meal. But here is what I need you to know right now. What you just threw away is being collected by agricultural companies, processed, packaged into glossy boxes, and sold back to organic farmers around the world for anywhere between 40 and 80 US dollars per kilogram. They call it chitin amendment, premium soil additive. You called it trash. So what is inside that ordinary shrimp shell that makes it worth that kind of money? The answer is not a mineral, not a vitamin, not some newly invented compound. It is a molecule over 500 million years old. And when you sprinkle it into soil, your plants will do something that no bottle of pesticide can replicate. They arm themselves. This is not folk wisdom. This is not unverified advice passed down through whispers. This is a biological mechanism documented in peer-reviewed studies from Cornell University, the University of Delaware, and dozens of agricultural research institutes across Europe over more than 4 decades. But for some reason, a reason we will address directly in this video, you have never heard of it. Before I explain the science, I want to take you back to a stretch of coastline on the eastern United States in the 1980s, where a group of scientists first realized something deeply strange was happening beneath the soil. And the answer had been sitting right under their feet for hundreds of years without anyone noticing. Chesapeake Bay, Maryland, the 1980s. This was one of the largest seafood harvesting regions in the United States. Blue crab, shrimp, oysters pulled from the water for centuries, and following a long-held tradition among local fishermen, the leftover shells after processing were not dumped back into the sea. They were spread across fields, mixed into garden soil, or simply piled near growing areas. No one could explain why. It was simply something passed down from grandparents. Do this, and the plants grow better, fewer pests, stronger through the winter. No reason needed. No evidence required. Just do it. But in 1983, a team of scientists from the United States Department of Agriculture began noticing something unusual. Soil samples taken from coastal Chesapeake areas where fishermen had been dumping shells for generations contained microbial communities entirely unlike standard agricultural soil. Not just richer, but harboring a specific group of bacteria with the ability to break down a tough, resistant polymer that most microorganisms cannot touch. These bacteria consume chitin, and as they consumed it, they released into the surrounding soil chemical signals that nearby plant roots immediately detected and responded to in a way that scientists at the time had never witnessed before. The plants were not simply absorbing nutrients. They were restructuring themselves from the inside, producing defensive compounds, thickening cell walls, activating biochemical pathways that normally only appear when a plant is under real attack from pests or disease. But there were no actual pests. There was no actual disease. Only decomposing crab shells in the dirt. This discovery was not unique to America. At almost the same moment, thousands of kilometers away, Japanese agronomists were studying the farming practices of fishermen along the Sanriku coast, a stretch of northeastern Japan famous for its crab and lobster trade since the 17th century. Here, coastal farmers had a tradition of grinding dried crab shells and scattering them around the base of rice plants and vegetables at the start of each growing season. Their yields were not just higher than inland farmers. Their crop loss rates from pests and disease were 34% lower, according to local agricultural records dating back to the 1920s. Over 60 years of data, no one had explained it. No one had even thought to ask why. It was not until 1989 that American scientist Joseph Kuch, one of the founding figures of modern plant immunity theory, formally published research connecting soil chitin to a phenomenon he called systemic acquired resistance, or SAR. This was the first time science gave a name to what Chesapeake fishermen and Sanriku farmers had been accidentally exploiting for hundreds of years without knowing what they were doing. The ancestors were right. They simply did not have the scientific language to explain it. And now we do, so let me show you what is actually happening inside that shrimp shell at the molecular level, and why a piece of kitchen waste can accomplish what a $1,000 bottle of pesticide cannot. To understand why shrimp shells can wake up a plant's immune system, you need to know something about the natural world that school never taught you. that life on this planet was built from very few original blueprints, and one of the most common, most ancient, most reused blueprints in the history of evolution is chitin. Chitin is a polysaccharide, a long chain of sugar molecules bonded together in a structure that creates extraordinary hardness, durability, and water resistance. It first appears in fossils from over 500 million years ago, and since then, evolution has reused it everywhere. The outer shell of shrimp, crab, and lobster, chitin. The exoskeleton of insects, from ants to beetles to stem-boring caterpillars, chitin. The cell walls of mold and fungal pathogens that attack plant roots, also chitin, the same molecule. Three entirely different groups of organisms, all of them potential enemies of the plants in your garden. This is the critical point you need to hold on to. Over hundreds of millions of years of evolution, plants learned one thing. When chitin is decomposing in the soil nearby, something dangerous is present. It might be insects tunneling through the roots. It might be fungal threads penetrating the stem. It might be both at once. Plants cannot see, cannot hear, cannot run, but they sense the chemistry of their environment with a precision we are still far from fully understanding. And the chemical signature of decomposing chitin is one of the oldest danger signals that plant roots are hardwired to detect. The mechanism works like this. When you scatter dry ground, shrimp shells into soil, beneficial bacteria in the earth, particularly Actinomycetes and Bacillus species, begins secreting an enzyme called chitinase to break down the shell material. This decomposition releases small fragments called chitin oligomers directly into the root zone. The outermost cell layer of the plant root contains specialized receptors. Think of them as ultra-sensitive antennas, designed to recognize exactly this type of molecular signal. When those receptors make contact with chitin oligomers, they immediately trigger a cascade of biochemical reactions inside the root cell, like someone pressing an emergency alarm button in a building. The signal spreads fast. Within hours, the plant begins producing a range of defensive compounds, protease inhibitors that prevent insects from digesting plant tissue, phenolic compounds toxic to fungal pathogens, and critically, a group of antimicrobial proteins called PR proteins, pathogenesis-related proteins, which the plant only manufactures when it believes it is under genuine attack. All of this happens without a single real insect, without a single real fungal thread. Only the chemical signal of decomposing shrimp shells. In other words, you are deceiving the plant. Not in any harmful sense, but in the sense that you are exploiting an evolutionary reflex honed over millions of years to protect plant life, and you are triggering it without an actual enemy present. The plant arms itself before the war begins. One thing I need to say clearly here, and I will not hide this from you, is that this mechanism does not work instantly like a spray. Chitin requires 7 to 14 days for soil bacteria to break it down sufficiently to release effective signal compounds. And if your soil has been treated with heavy chemical inputs for years, with a depleted microbial community, this process will be significantly slower. This is the real limitation of the method. And I say this not to discourage you, but so you understand it accurately. This is not an instant chemical weapon. This is a long-term biological defense system. But when it works, and in healthy soil, it works remarkably well, what happens next inside the plant is genuinely astonishing. Because chitin does not only trigger localized defense at the root level, it activates what science calls systemic acquired resistance, an immune response that spreads through the entire plant, from root to stem, from leaf to fruit, by a mechanism that still astonishes plant biologists to this day. Let me offer a comparison before going deeper into the science. When you were young, the first time you had chickenpox, your body went through a brutal biological battle, high fever, rash, exhaustion. But after you recovered, your immune system remembered the enemy. The second time that virus entered your body, it was neutralized within hours before you had a single symptom. That is acquired immunity. SAR in plants operates on the same principle, but with one staggering difference. The plant does not need to actually get sick to activate it. Chitin in the soil is the fake vaccine. Enough to fool the system, not enough to cause harm. When chitin oligomers activate receptors in the root, root cells begin synthesizing and releasing jasmonic acid, a plant hormone that travels through the plant's vascular system like an urgent phone signal being forwarded across an entire network. Jasmonic acid moves from root to stem, from stem to each branch, from branch into every leaf petiole. That entire journey takes only a few hours, and at each stop along the way, it triggers a local response. Cells at that location begin producing their own defensive compounds. But jasmonic acid does not work alone. In parallel, another molecule is activated, salicylic acid, which you may have encountered in a different context. Aspirin was first synthesized based on the structure of this very compound. In plants, salicylic acid plays a different role. It acts as a systemic signal, amplifying and sustaining the heightened state of alertness across the entire organism after jasmonate has set it in motion. These two molecules work in concert to create what scientists call a prime state, a condition in which the entire plant is not only actively defending itself, but waiting, and any real attack signal that arrives will be met faster and far more powerfully than in a plant that has not been primed through SAR. A 2003 field study from Cornell University on tomato plants found that those treated with soil chitin had a 41% lower rate of Fusarium infection, one of the most destructive fungal pathogens in vegetable crops, compared to the control group after 8 weeks. On pepper plants, a University of Delaware trial recorded a 38% reduction in damage from fruit-boring insects in the group receiving chitin treatment every 4 weeks. Not 5%, not 10%, nearly 40% from something you throw in the trash every week. And this is the moment I want you to pause for just a second. If you are watching this video, chances are you are someone who grows food with your own hands, who tends your own garden, who is looking for ways to build healthier plants without depending on expensive bottles placed in front of you at every agricultural supply store. That means you are not a passive consumer. You are someone who has chosen to be self-reliant. And SR is the tool for people like you, one that has existed for hundreds of millions of years in nature, waiting to be recognized and used. So why have you never heard of this? Why has no one, no plant doctor, no agricultural engineer, no salesperson at a garden supply store, ever proactively told you that the shrimp shells in your kitchen could replace a significant portion of what they are selling? The answer is not accidental, and it connects directly to a $70 billion per year industry, a figure we need to address directly in the next section. In 2022, the global pesticide market was valued at exactly $70.3 billion US dollars. To put that number in perspective, that is the entire GDP of Croatia, or roughly equivalent to Germany's full defense budget for 1 year. $70 billion generated by selling farmers and gardeners across the world. Bottles, packets, and sprays with the implicit promise that without them, your plants will die. Now ask yourself this question. If a zero-cost method existed that could reduce pesticide dependency by 30 to 40%, had been proven by science since the 1980s, and its raw material was something that billions of people throw in the garbage every single day, what would happen to those $70 billion if this information became widely known? I am not suggesting there was a secret meeting in a locked boardroom somewhere where executives decided to deliberately erase all knowledge of chitin. Reality is usually more mundane and more insidious than conspiracy. What actually happened is this. Research on chitin and SAR exists in specialized scientific journals. The Journal of Plant Pathology, Phytopathology, Soil Biology, and Biochemistry. Journals that no ordinary gardener ever reads. That research was never translated into practical guides, never incorporated into agricultural extension programs, never printed on any product label, because no company profits from telling you to use free shrimp shells. Instead, large corporations saw the commercial potential of chitin very early. American company Primacor, Belgian conglomerate Ketozyme, and dozens of other manufacturers beginning in the 1990s started extracting chitin from industrial seafood waste, exactly what you have in your kitchen, refining it, drying it, packaging it, and selling it back at $40 to $80 per kilogram under scientific-sounding brand names, Cheetoplant, Biogitin, Root Shield Plus. Same molecule, same biological mechanism, The only difference is that one cost money and one you were throwing away. Here is the direct comparison I want you to remember. 500 grams of mid-range commercial agricultural chitin powder on the current market costs approximately $25 to $35, sufficient to treat roughly 10 square meters of soil. Fresh shrimp shells, when dried, retain approximately 30 to 35% of their original weight as pure chitin and cost you nothing. A family seafood dinner for four can yield enough shrimp shells to treat an entire 5-meter vegetable bed, free from waste. And that $70 billion industry did not only sell you chemical pesticides. In recent years, as the organic movement surged, they simply pivoted, selling you the very thing they had long known you could make yourself, repackaged as refined products with beautiful labeling and organic certification. The biological crop protection market, which includes commercial chitin products, is growing at 15% per year and is projected to reach $12 billion by 2027. $12 billion from selling back to you what your ancestors already knew how to use for free centuries ago. Knowledge does not disappear. It simply gets repackaged and sold back to you at a premium. But now you know, and knowing alone is not enough. You need to know exactly how to turn that kitchen waste into a real biological weapon for your garden. Step by step, number by number, with nothing left vague. This is the section you have been waiting for. And I will not let you down. No theory, no detours. Only specific steps, real numbers, and everything you need to get it right the first time. The first step is collecting and preparing your raw material. Shrimp shells, crab shells, lobster shells, mantis shrimp shells. All of them work because all belong to the crustacean family and all contain chitin at high concentrations. Shrimp shells contain approximately 20 to 30% chitin by dry weight, crab shells 15 to 25%, lobster shells up to 35%, the highest in the group. After a meal, instead of throwing the shells in the trash, collect them in a basket or tray, rinse them briefly with clean water to remove salt and seasonings if present. High salt concentrations can harm soil microorganisms, and leave them to drain. Next comes drying, and this is the most important step, the one people most often skip. You need to dry the shells under direct sunlight for 2 to 3 days until they are completely brittle, snapping easily with no remaining flexibility. Shells that are not fully dried when buried in soil will ferment rather than decompose correctly, producing ammonia gas, attracting flies, and potentially damaging young roots rather than protecting them. If sunlight is unavailable, you can dry them in an oven at 80 to 100 degrees Celsius for approximately 1 hour. The test is simple. The shells must be as crisp as dry crackers, with none of the characteristic raw seafood smell remaining. Once completely dry, the next step is grinding. You do not need industrial equipment, a stone mortar, a small hammer, or simply sealing the shells in a Ziploc bag and rolling over them with a glass bottle is sufficient. The goal is fragments between 1 and 3 millimeters in size. They do not need to be as fine as powder, but large intact pieces should not remain. The smaller the fragment, the greater the surface area in contact with soil bacteria, and the faster the process of chitin decomposition and signal release. A 2007 study from the University of Rhode Island found that shells ground to under 2 millimeters produced a measurable SAR response within 7 days, while fragments larger than 5 millimeters required up to 3 weeks to achieve equivalent results. On dosage, and this is the number to write down, the recommended application rate is 100 to 150 grams of dry ground shell per square meter of soil. Approximately 1 large handful. Scatter evenly over the soil surface around plant bases, keeping 5 to 10 centimeters away from the stem to avoid direct contact with young roots. Then use a hand tool or your fingers to mix the shells lightly into the top 3 to 5 centimeters of soil. No need to bury them deep. The chitin-digesting bacteria that drive this process are most active in the topsoil, where oxygen is still abundant. Application frequency is every 4 to 6 weeks throughout the growing season, not once and done. SAR is best maintained with a steady low-level supply of chitin entering the soil continuously, the way you take vitamins daily rather than swallowing an entire bottle at once. After the first application, the most visible change typically arrives in the 2nd and 3rd weeks. Leaves firmer, more lustrous, and most importantly, visible signs of pest pressure beginning to decline noticeably. Plant types that respond best include tomatoes, peppers, eggplant, cucumber, squash, and most leafy greens such as cabbage, lettuce, and water spinach. Legumes also respond positively. Woody fruit trees such as guava, citrus, and papaya respond more slowly but show meaningful improvement after 2 to 3 consecutive application cycles. But I need to be honest with you about something important. And this is the real limitation of the method I mentioned earlier. Chitin works through soil microorganisms. If your soil has been treated with chemical pesticides, herbicides, or high doses of synthetic fertilizers for many years, the microbial community may be damaged severely enough that there are no longer sufficient chitinase-producing bacteria to break down chitin effectively. In that case, you will need to combine this method with mature organic compost or vermicompost to restore microbial life, either before or alongside your chitin applications. The healthier the soil, the more powerfully chitin performs. This is not a failure of the method. It is a reminder that your garden is a living ecosystem, not an inert container. One final warning about dosage: more is not better. Applying over 200 grams per square meter in a single application can create an excessive chitin decomposition load, triggering a surge in chitin-digesting bacterial populations, which consume nitrogen in the soil rapidly, leading to localized nitrogen deficiency, pale yellowing leaves, and slowed growth for 1 to 2 weeks. Not dangerous, but alarming if you do not know the cause. Correct dose, consistent timing, patient execution, those are the 3 words to keep with you. You have the material, you have the method, you have the science behind you. The only thing remaining is the decision. Will you keep throwing this into the trash tonight, or will you start something different? Look back at the journey we just traveled in this video. We started from a shrimp shell in a trash can. We walked through the coastal lands of Chesapeake Bay, where fishermen were accidentally doing the right thing 40 years before science could explain why. We looked inside a plant root cell and found a defense system refined over hundreds of millions of years, waiting to be activated. And we looked directly at the number $70 billion, the scale of an industry built in part on your lack of information. You are not ignorant. You are not careless. You simply did not know because no one with a financial interest in telling you ever did. And that is the most important distinction I want you to carry with you after this video ends. A self-reliant grower is not the person with the biggest garden or the highest spending on agricultural supplies. A self-reliant grower is someone who understands enough about what is happening beneath their soil to no longer need any bottle placed in front of them. And today, you have become that person. If this video has changed the way you look at a shrimp shell after dinner, if it makes you pause for just 1 second before dropping it in the bin, then I want you to do one thing. Not to support this channel, not to boost views or feed an algorithm, but because the friend, the neighbor, the family member growing vegetables beside you also deserves to know this. Sharing this video is an act of refusal, refusing to let this information stay buried one more time. And if you want to keep going deeper into knowledge like this, things that have existed for centuries but were pushed to the margins because no one could profit from them, then subscribing is not pressing a button. It is choosing to stand on the side of free knowledge. And in the next video, I will show you why another piece of kitchen waste you throw away every morning contains the secret to making your garden soil hold water 3 times longer without a single extra drop of irrigation through an entire dry season. A discovery from a civilization that vanished 600 years ago, accidentally unearthed by Brazilian scientists in 1980 who could not believe what they were looking at.